Hello friends, welcome to this channel, and after a gap of almost 2 months, we are back with the second session in this series on the discussion of the configuration of Siemens decentralized busbar protection using Digsi 4 software. So hopefully we will continue with these sessions regularly from now onwards, and I regret for this long delay between the first session and the second session of this series. So now, without wasting any time, let us start with our today's session. In this session, we will discuss that how to link these bay units, that is the bay units which we have created in our first session, to the central unit. If you remember, when in the first session we have already discussed about the busbar topologies, that is how to create a busbar topology for 1.5 breaker scheme. And during that session we have considered that we are using or we are considering 8 bay units, 4 of which are connected to bus 1 and the remaining 4 are connected to bus 2, and we have drawn the topology in the same way. So I am again using the same project which you can see on this screen, that is the busbar English demo, and here you can see this 7SS522, which is a central unit followed by 8 bay units. Now if you open this in the offline mode, then uh, since in the last session I have not assigned any bay unit, so it is showing you that not all bay units are assigned to SIPROTEC device. For the time being, just click OK. And now if you see here in the settings, last time or in the first session I have already discussed about this substation configuration, that is how to draw this bay units, or how to draw the isolator breaker, what the importance of CT polarity, and how to select whether to the CT is pointing towards busbar or away from busbar. Similarly, we have also drawn for busbar 2, if you see here, busbar 2, and I assume that the even numbered bay unit, that is 702, 4, 6 and 8 are connected to bus 2, while the odd numbers like 701, 3, 5, 7 it is connected to bus 1. Further, we have assumed that this is a 1.5 breaker scheme wherein your bay units, or particularly your CTs, which are connected to any particular bus, it will remain connected to that particular bus throughout, and it doesn't depends upon any isolator status. That's why we have connected these disconnectors in such a way that this is already in closed position or in on position throughout. So now if you see in the bus bar 2 also, these are 70289 on, 70489 on, 706 and 889 on. Then we have added some measuring blocks in this topology, and all these things we have already discussed in our first session. So now we have to assign the bay unit. So for that, go to this bay unit allocation, and this is very simple. So now we have to define which particular bay unit that you have added in the project belongs to bay unit 1, which bay unit belongs to bay unit 2, and like that. So first the bay unit 1. So just click here, and now you can see the all 8 bay units that we have added in the projects. And suppose for the time being that your bay unit that you have added in the projects are in the same order, like 701 is as bay unit 1, 702 is bay unit 2, 703 is bay unit 3, since we are creating the project for the first time. Now in future it might happen that some of the bay units which are not connected and or in the some, suppose 707 is future bay, so you can skip this 707, or you can connect the 707 also. If you skip this 707 urgently, then in future when you add this 707, that it will be suppose bay unit 8 or bay unit 9, it cannot be bay unit 7, because presently the bay unit 7 will be 708. So now this is very simple thing. Suppose bay unit 1, so just select 701 as bay unit 1. 70 now once you have selected 701, so that is not available in the drop down, select 702 as bay unit 2. Similarly, select 703 as bay unit 3, 704 as bay unit 4, 705 as bay unit 5, 706 as bay unit 6, 707 as bay unit 7, and 708 as bay unit 8. Then click OK. And once you save, then all these bay units will be allocated. And now if you see here bay units, so now all these bay units will be available to you at this point, that is under bay unit heading. And here you can set the parameters like the breaker failure settings, the end fault settings, the breakers uh, setting, and I will discuss about all these settings and due course of time in the coming sessions. So once you have selected or once you have assigned the bay units, what you have to do is just click on save, and once you save, it will be completed. So now once you have assigned the bay units, then the next step is which bay unit you want to keep in service and which other bay unit you want to keep out of service. So, of course, if you have, suppose, 8 bays, that is 4 connected on bus 1 and 4 connected on bus 2, and all these are in service, or suppose all these feeders will be in service in coming days, and you are configuring the bus bar for that purpose, then you have to keep all bay units in service. So just click on bay units, go to bay unit 1. By default, every bay status will be in service. So display additional setting, I will discuss about these settings in due course of time. So just click on any bay units, and there you will see the two options, that is in service, out of service, and maintenance mode. I will discuss about maintenance mode later on during our sessions, but in service and out of service, when you keep any bay unit in service, then only its current will be contributed, or its current will be reflected in your differential and stabilization calculation of the bus zone. If you keep any bay unit out of service, then its current will not be reflected into your uh, bus bus zone differential and stabilization current. So generally, all bay units must be kept in service, uh, except when you are doing any work, and or except when some of your suppose one of your bay unit is faulty and you want to keep that bay unit out of service, then you can do that. But once you are keeping any bay unit out of service, then since that current will not be there in your differential zones, or differential and stabilization zones of particular bus bar 1 or bus bar 2, so unnecessarily your bus bar will be in block condition, or it will give you a block alarm. So you have to keep your bus bar in the blocking position, or you have to keep your bus bar out of service when you are keeping your bay unit out of service. So I will discuss about these things also during this masking IO configuration. So now the next thing, once you have assigned these bay units, it is very simple, nothing else is required to be done. Group of parameters I will discuss in the next session, or group of parameters I will discuss in this session itself, so that in the next session we will discuss about the bay units. So generally, this is our basic settings of 7SS522 central units, and I will discuss about only the important settings that you have to implement. So first setting is minimum duration of trip command. You can set it as 100 or 150 millisecond depending upon the extended setting template of your substation. And the important setting over here is your control release for bay units. So if I am selecting this as release, then I can control the bay units from the central unit, and if I am using this as block, then I cannot control the bay units from our central units. So this is the very basic setting. Then the next tab, that is bus bar protection, and the bus bar protection, you will have three different settings. One is your stabilization factor, second is your differential current threshold, and then your cross stabilization. Basically, the two most important settings are the stabilization factor and differential current threshold. Differential current threshold is basically, if you see here, I divided by INO. INO is the nominal object current. For example, for a 2000 or 3000 ampere CT, this will be 2000 ampere or 3000 ampere. And differential current threshold means the minimum current that the relay if this current is above this value, then only your relay will issue a trip command. So if suppose this is a 2000 ampere rated CT, so that means a minimum of 2000 ampere current is required in the differential zone before it picks up. And then this stabilization factor, basically this stabilization factor means it is a slope. So once your differential current is above 2000 ampere, then it is going to calculate, or by calculating the differential and stabilization current, simply it will multiply your stabilized current with this factor of 0.65, and if the differential current is more than this, then only the relay will issue a trip command. Similarly, for check zone, these two factors, that is stabilization factor is basically slope, and differential current threshold is this simple minimum pickup. Generally, in this all modern numerical relays, we are using only bus zone. Check zone is uh, not the same concept like the earlier high impedance technologies, where we have discussed that the check zone is from different CT cores. Uh, Although these relay are calculating the check zone current, bus zone current, but generally those check zones are through the same CT core. So once your any CT there is any issue in one of the CT core, suppose core 1, then definitely your bus bar protection main one will be in the block state. So now next is breaker failure protection. So this breaker failure protection over here, this is using stabilization factor breaker failure protection for this slope, and this is a different kind of breaker failure protection that I will discuss in the next session, wherein we will discuss in detail about the breaker failure protection, that is how this factor comes into picture and in which conditions. Then the monitoring is very important. So if you see monitoring, so the important settings over here is, first of all, differential current supervision. So differential current supervision means suppose there is any issue in your CT circuit or any issue in the secondary circuit, and we are having some differential current in our relay, and that differential current is suppose less than the minimum threshold, but it is some appreciable amount that might be due to the problem in the CT secondary circuit. So in that case, your relay must issue an alarm so that we can diagnose the problem and we can rectify the problem before taking the bus bar into service. So if you see here, differential current supervision, it must be kept on. And now the difference time delay for differential current supervision. So what does this means? First of all, you have to set a value of minimum differential current level supervision. Suppose I am using this at 0.1 and this is at 2000 amperes rated CT. That means whenever there is a current of 200 ampere in the differential zone for more than 2 seconds, then this relay will give you a differential current supervision alarm. And now you can select what you want to do with this differential current supervision alarm. So generally for bus zones, we use the blocking during the fault. So that means if there is any problem, here the fault means the current in the differential zone which is above this current supervision. This fault doesn't means the bus bar fault. So whenever the differential current in the differential zone is more than this 0.1 ampere for 2 seconds, then your bus zone will be blocked till this current is above this level. For check zone, the default setting is alarm without blocking, because once you have set this parameter, as per the template of your substation, we move on to the next, which is zero crossing supervision. So zero crossing supervision is generally used for the DC offset in the current. Generally, this is the internal feature of the relay. So whenever this 7SS522 decentralized busbar protection relay is used for the protection of any busbar. And if this relay doesn't detect a zero crossing in suppose 1 or 2 cycles, then it will automatically block. So suppose there is a high DC offset in our current, and it might happen that one positive half cycle and then the next half cycle which relay for a 50 hertz system. Suppose your zero crossing comes at every 10 millisecond, but the relay is not getting the zero crossing in suppose 20 or 30 milliseconds, then it will detect that there is a high DC components in your primary fault circuit, and it is a primary in this fault or in the primary circuit there is a high DC component, and this relay will automatically going to block itself. So we can set this threshold for zero crossing supervision, that is how much current it has to see before going into the blocking mode. Then the next is CB and or disconnector supervision. So this is again a very simple thing. Once you say here the CB supervision and disconnected supervision time, so when this comes into picture, first is suppose there are two different things. So one is your disconnector can malfunction, or a status can malfunction, or a state you can have a DC fail. So what is the difference between these two? Malfunction means suppose your disconnector open and close, both status is coming as or reporting as high in your central unit or in the bay unit, and through from bay unit to the central unit. And in DC fail, what happens is your open status as well as closed status both will be in the low state. So now these two are not suitable for any detection in case of your reconfigurable bus bar, because these types of problem have no impact in case of 1.5 breaker schemes where your zones are permanently fixed or your CTs are permanently fixed to the zones. So if suppose your disconnector malfunction, so suppose there is a DC fail and open and closed status both are not coming to the relay, so you can select whether you want old disconnector status or you want a permanent on status. This is again a choice you have to make, and this comes with experience. This comes and this generally is different with different utilities, whatever philosophy your utilities might be using, that you have to see. Then once you have selected this as old disconnector status or on, then next thing is reaction on disconnector malfunction. So suppose your disconnector is malfunctioning or your status is not proper, you can select whether you want alarm without blocking or blocking till this is present, that is during the fault everywhere in these settings means till these conditions persist, and blocking unit release, blocking until release, or blocking until acknowledge. So until you acknowledge or until you release these things, it will keep on blocking. So this again generally it is alarm without blocking, but you can select anything as per your requirement. So this is the basic settings under the central unit. In the next session, we will discuss about the bay units in greater details, and we will discuss about the settings of the bay unit followed by the different signals inside bay units, and then we will discuss how to configure the bay units. Hopefully after those, and then the slight discussion about masking IO, you will be in a position to configure Siemens decentralized busbar unit. And for better understanding, it is also advisable that uh, you see your project in some separate laptop, the project of your substation in your laptop, and then try to understand the configuration, to try to understand the settings that are implemented using your schemes, using your utility philosophy, and then it will be uh, easier to understand this bus bar configuration. So we will keep this session only up to this point. And if you like this session, and if you think that this video or these sessions are useful to you or other protection engineers that you might know, then you might share, or you may share this video with your friends also, so that they may understand these concepts and they may use these concepts at their organizations also. So thank you, and hopefully we will meet again very shortly with the next session on this series. Till then, thank you and goodbye.